MCV4U1 Chapter 3 Applications of Derivatives Session 8. In this session we are going to work on exercise 3.3. Question 8. A net enclosure for practicing golf shots is open at one end as shown. Find the dimension that will minimize the amount of netting needed and give a volume of 144 meters squared. Netting is required only on one side, the top and the far end. The area is the area of far end plus the area of top and the sides, which is x2 plus 3xy. x2y is the volume, which is 144, therefore y is 144 divided by x2. The only restriction that we have here, x should be greater than 0. The area as a function of x would be 3x times 144x2 plus x2, which is the same as x2 plus 144 times 3, which is 432 divided by x. A prime of x is 2x minus 432 over x2, which is the same as 2 times x3 minus 216 divided by x2. If we set the derivative to 0, x would be 6 and y would be 4. To see x equals 6 minimizes ax, we have to look at the sign of the rate of change. At 6 it is 0, between 0 and 6 it is negative, and after 6 it is positive. This means rate of change is decreasing when x is between 0 and 6. And after 6 it is increasing, which means when x is 6, a and x is minimum. We will study this in next chapter, how to find maximum minimum of a function. Therefore, the enclosure should have the dimensions of 4, 6, and 6 meters to minimize the netting. Next question is question number 14. The 6 segments of window frame shown in the diagram are to be constructed from a piece of window framing material 6 meters in length. A carpenter wants to build a frame for a rural Gothic style window, this type of windows, where triangle ABC is equilateral. Let's assume BC is X and CD is H. Since triangle is equilateral, we have three sides of the triangle equals x, and the total material that we need is 2h plus 4x, that must be 6 meters. This means h is 6 minus 2x. This window must fit inside a space that is 1 meters wide and 3 meters height. Reduce it by 2, so this is 3 minus 2x. X is obviously positive because it is length of the side of the triangle. Therefore, h is definitely less than 3. And x must be less than 1 because the window must fit inside a space that is 1 meter wide and 3 meters height. If x is between 0 and 1, then definitely the height is less than 3. Now we rate the area, which is xh plus x2 root 3 over 4. If the three sides of an equilateral triangle is x, then height would be x root 3 over 2. Therefore, the area is x2 root 3 over 4. From here, area is 3x minus 2x2 plus x2 root 3 over 4. And x should be between 0 and 1. The derivative of the area is 3 minus 4x plus half of x root 3. If we set it to 0 and solve the equation, x would be 0.96. X is between 0 and 1, and 0.96 makes the derivative 0. A at 0 is 0. A at 0.96 is 1.43, and A at 1 is 1 plus root 3 over 4. This means the maximum area is when x is 0.96. In this case, the dimension of the window is 0.96 as x, and h is 1.09. And if we check, we see all the materials is used. The next question is question number 15. A train leaves the station at 10 a.m. and travels due south at the speed of 60 kilometers per hour. Another train has been heading due west at 45 kilometers per hour and reaches the same station at 11. At what time the distance between two trains is minimum? Train A is going south and the other train is going west towards the station. The distance between two trains can be found using the equation z to the power of 2 equals s a to the power of 2 plus sp to the power of 2. Sa is 60 times t. The train moving south at a speed of 60 after t hours. It is 60t. And the other train is moving with the speed of 45. Therefore, the distance between M, if we assume the other train is at point M at 10 a.m., to a station is 45 kilometers. The train B reaches the station in 1 hour and it's moving with the speed of 45. This means SB is 45 minus 45 t, because it goes in t hours, it goes 45 times t. SB is 45 minus 45 t. Therefore, Z is square root of 3600 T2 plus 45 to the power of 2 times 1 minus t to the power of 2. T is between 0 and 1. If we find the derivative of this function, the derivative with respect to t would be 7200 t minus 4050 times 1 minus t. We have to times it by 1 over 2 because this is the derivative of g of x to the power of 1 over 2 if we g of t to the power of 1 over 2 if we assume the expression on the radical is g of t. The derivative of this is 1 over 2 times gt to the power of negative 1 over 2 times g prime of t. G prime of t is here, and the other part can be written as 2 square root of g of t, which is 3600 t2 plus 45 to the power of 2 times 1 minus t to the power of 2. If we set the derivative to 0, we'll see t is 0.36. What we have to do is following the algorithm. T, S at t, 0, 0.36, and 1. At 0, the distance between two trains is 45. At 1, the distance between two trains is 60. At 0.36, the distance between two trains is 36. Here we call the distance between them z at t. We use this equation to find the values. The minimum is when t is 0.36 and it is 36 kilometers. Thanks for watching.